Okay, I don't see that on YouTube though, but I'm sure there's a lag. Hey guys, good evening. Good evening one more time because we are not meeting for the first time, certainly. You must have joined me in my previous classes. Today's session, it's all about allegation. Many of you must be very new to this topic, new to this word itself, allegation. Before we begin there, some intro discussions and then I'll jump into the topic. These 60-minute sessions are designed in order to help you with some concepts which are tested frequently on the GMAT. It also helps to give you a revision in case you've already completed these topics, but just practicing question, refining the thought processes helps you to fine tune on the topic, right? So this 60 minutes, just be present with me, mindful and here now as in, try taking the most out of the discussion that we are having, the conversation that we are having now. When I say conversation, I'd like you all to place your thought processes on the chat. I'd like you all to put across any questions that you have, but I'm going to take the questions at the end of the class so that the flow of the discussion is not broken. If it's something that is completely connected with what I'm discussing, it should be it should be taken live directly while you have been asked the question. As far as me, my name is Devamitra, and I head the academic segment of Crack Verbal here. I love working with numbers, so I'm into quant and data insights. And one of my superpowers is to be able to give you exact, precise inputs if you give me the right data points in terms of your prep. So I've been doing that for quite some time with the students. So if you have an error log ready, if you have the mock test course ready, reach out to me, discuss with me, and just follow the inputs that I give to you. I'm pretty confident that if you follow what I'm saying, you will definitely change the score from wherever you are to an upgraded score based on the timeline that you have, based on the preparation that you're doing. Okay? So that's about me. I'm Devamitra. Moving on from this point about the agenda of the meeting. Now, before we start allegation, what I'm going to do is I'm going to give you some basics about ratios and weighted average. There may be many of you who might not be very, you're probably not using ratios and weighted average a lot on your questions, but that amount of basics is necessary before we touch base on allegation. And when I teach you allegation, I'll teach you largely through questions, GMAT questions. I'll show you how it is utilized, where all we can utilize allegation, and how we need to create a mental algorithm in order to attack the GMAT problems and solve them very quickly with the technique called allegation. All right? So let's go. Let's start with a bit about ratios. So the mindset of ratios can be understood with a simple example. Like, for example, there's a classroom, and then there are boys and girls in the ratio 2:3. This only implies that whatever be the total number of students, two parts of it occupied by the boys and three parts of it by the girls. So total number of students can be divided equally in five parts. Five equal parts can be the total number of the students can be divided in it. So suppose I give you a total of say 120. We can reverse engineer from this bit and find out the total number of boys, the total number of girls. Because if we have 120 representing the five parts, I can equate five parts with 120 and find out the value of each part. So one part will be equal to 120 by 5, which is 24. And once we have each part, we can find out two parts is how much, which is 2 times 24 or 48 boys. And we can have 3 times 24 representing the girls, which is 72 girls. Now, this also implies that if you add them up, the five parts will amount to 120 students. It could also be given, suppose instead of giving you total is 120, I would have given you the number of boys is, say, 36 boys, not 48, but 36 boys. then all you need to do is reverse engineer from the ratio that is given to you and now utilize these two parts and equate that to 36. If I gave you total number of boys is equal to 36. Two part is 36 boys and your intent is to reach to that one part. So one part will be equivalent to 36 by 2 or 18. If I found out one part, then you have to find out three parts. 3 into 18, 54 girls. So given the ratio, given a particular value, you can always manipulate or operate back from that, use reverse engineering and find out that if total parts are given to you equated with a value, you can find out one part and solve for the unknown two part and three part. If one of two or three parts is given, you can find out again the value of one part and find out the value of three parts and the total five parts. Sometimes the question might give you the difference. They might give you the difference between boys and girls. Say the difference given to you is 20. The difference is three part minus two part. One part is equivalent to 20. For example, if the difference between boys and girls in a class is 20. Given one part is 20, you can again utilize the value of two parts, find out 2 times 20 is equal to 40 boys, and three parts, which is 3 times 20, is equivalent to 60 girls. So using ratios, you can always find out the value of one part, then go to find out the value of the unknowns that has been asked to you. This is the core basics we'll be utilizing today when we deal with the concept of alligation. Not only this, now that we have covered ratios, I'd like you to understand, stay with me, to understand weighted average. When I say weighted average, let me erase the screen. The meaning of the word weights is proportion. Weights is the quantity. The quantity that creates a different sum is called the weighted weights for a particular scenario. For example, let's say there are two classrooms A and B. The average score of classroom A students is 10. The average score of classroom B students is 20, for example. There are 5 students in classroom A and 15 students in classroom B. If we go to find out the average score, the average here will need to include the weights 5 and 15. Okay? So when I say 5 and 15, I have to find the average by finding the sum of the scores in classroom A, which is 5 times 10. Sum of the scores in classroom B, which is 15 times 20. Add it up and divide it with the total number of students, which in this case is 5 plus 15 or 20 students. This becomes the weighted average. What did I use as weights? I used 5 students and 15 students. Because these 5 students have a different average score, these 15 students have a different average score. So this is how you find the weighted average. So this would be 50 plus 350 by 20, 17 and a half. This would be the weighted average when you combine the classes. Now that you understood about ratios and weighted average, I will take you to the next step, which is understanding alligation. And even when we're talking about alligation, we'll understand where on the GMAT are we supposed to use alligation. Does it click like that? How does it reduce our time? First, let's also understand when should we use alligation. Now, whenever you're dealing with a GMAT question that wants you to combine or mix percentages, 50% concentration of oil mixed with 30% concentration of oil. We are dealing with mixing percentages. That's when we can think about alligation as a technique. If you're trying to combine, if not percentages, if you're trying to combine ratios, fractions, which are also percentages when multiplied with 100, you can think of using alligation. When you're dealing with averages, you can also think of finding out the answer by using the concept of alligation. If you're dealing with combining or mixing costs, $150 per kg of potatoes is mixed with $40 per kg of another variety of potatoes. Then when you mix it, what is the average value of the mixture? That kind of question when you're mixing costs, or one of those kinds where you're mixing speeds. 50 kilometer per hour combined with 150 kilometer per hour, two objects moving, then you can also think about alligation. So alligation is like a tool in your GMAT toolbox. Just like ratios is a tool, percentages is a tool. Alligation is also a tool that helps you reduce the timing on questions that can be solved using alligation. What you really need to focus on when you're using alligation is practicing multiple questions and deciding when to utilize alligation as an approach. So this is about when you should be using alligation. Every question when we solve today, I will want you to understand why should I even use alligation here? Because that is a skill you need on the GMAT. How to use alligation, it doesn't take a lot of time to understand that. Okay? So 1, 2, 3, 4, 5. And you would notice in each of these cases, we can utilize alligation because the values that we are using, they are associated with the word per. So the values associated with per is an indicator that you can utilize alligation. Percentage, 50%, 60% combined. Ratios or fractions, out of how much. So per unit, what is the value you're utilizing can be utilized because that's where we can use alligation. Averages. So in a classroom, 80 marks per student is the average. There are 10 students. So this is also something where we can use alligation because we are trying to find out that we have been provided with value per student. $150 per kg. Again, values associated with per. 50 miles per hour, 150 miles per hour. These are values associated with the word per. So this becomes a key indicator of when to utilize alligation. Now, one step is done, identifying where I can use this technique. The next question would be, how do I use this technique? So what we do here is we make an alligation diagram. There are 4 arms. And associated with these 4 arms, we have a few values. We have higher value represented with HV, lower value associated with LV, and MV as the mean value. So naturally, mean is the arithmetic mean or average. It lies between the higher value and the lower value. Mean has to be lesser than the higher value and greater than the lower value. That is the nature of arithmetic mean. What are these higher value and lower value? What we talked about earlier, values associated with the word per. So percentage, kilometer per hour, price per unit, averages, they're all values you can utilize when you're dealing with alligation. Now, make sure that there is an overlap between these 3 quantities. So if you're combining alcohol and water, and you're using the concentration of alcohol for higher value, you have to use the concentration of alcohol for the lower and the mean value. You can't use alcohol for higher value, water for the lower value. You can't do that. There has to be an overlap between the quantities that you're using. Once you've understood what are the higher value and lower value and mean value, make sure that you identify the quantities being used. And mean value will correspond to quantity 1 plus quantity 2. Now subtract along the diagonals. When you subtract along the diagonals like this, knowing that mean value is lesser than the higher value, you're going to write HV minus LV. Let me use black here. HV minus mean value. And when you're solving around this diagonal, it's MV minus LV because mean value is greater than the lower value. Now this is the ratio you're working with. This ratio is equal to the ratio of the quantities involved. Now from this ratio, using the basic fundamental aspects, knowledge of ratios, you can reverse engineer and solve for the unknown value. Your skill is to identify where to use alligation, skill number 1 on the GMAT. Second skill, what are my higher value, lower value, and mean value on that question? And try understanding what is my overlapping quantity. Is it alcohol? Is it water? What is that value I can figure out for each of them? And second, utilize that overlapping quantity, reverse engineer from it, and find the unknown. Either they would give you the total, that means they've given you the sum of these 2 values, or they would give you one of them, ask you the other value. That's why I mentioned reverse engineer on the problem. Let's take it with an example. Here's a question, okay? I'm going to solve this question with two approaches. One where we need to understand what happens when we use equations on this problem. We have to understand that. Then I will show you how we can use alligation on this problem. A solution. Let's put it visually and understand first. A solution of 150 liters contains 40% oil. How many liters of pure water must be added to reduce the overall oil concentration to 25%? 150 liters with 40% oil. So if I have 150 liters, then I know 40% of 150 is equal to 60 liters. So I have 60 liters of oil floating on 90 liters of water. The question asks you to mix pure water in it. Now, pure water has no oil. It is 100% water. Concentration is 100% water. I don't know how many liters. Let's just write X liters. The overall quantity now reduces to 25%. The concentration of oil naturally reduces to 25% because you're diluting it. If I had to set up an equation, this overall volume here is 150 plus X liters, 150 and X. The overall volume of the mixture is 150 plus X. So if I had to set up an equation here, right, I would focus on the quantity that is overlapping. In the result, we have 25% oil. In the question, in the information given, I know that there is 60 liters of oil. But what we add here, the water, has no oil. There is no oil in water, right? Which implies that all the oil that is represented by 25% is basically equal to 60 liters. Now, if you could realize this much from the question, you could set up an equation which would say the oil of 60 liter by volume, 60 liters of oil would be equal to 25% of 150 plus X. 25% of the overall new mixture, 25% of 150 plus X will be equal to the amount of oil, which is 60 liters. Now you can solve for it. You can solve for this and say, find out X to be equal to 90 liters once you solve it. And many of you will not even need to solve it if you're using percentages because, 25% is 1/4. 1/4 is equal to 60. So 100% is 240. And you need to add 90 in order to get 240 with 150. You could use percentages to solve. Now, this is one way to solve the question by setting up of an equation. The other way to solve the problem is when I don't set up equations and I set up an alligation diagram because I decided to use alligation. Since I'm dealing with concentrations, I'm dealing with 40% and I'm dealing with 60%, with 25%, 40% and 25%. Let's try to utilize alligation as a technique here. If I did use alligation, higher value, I'm going to write here so that you understand what are higher values, lower values, mean value. The four arms here. I'm going to use the overlapping quantity here of water, right? I have water here. I have water here. I also have water here. So it is convenient to use the overlapping quantity. It's not like you can't find the answer if I use oil. You can find the same answer, exactly same answer, just more convenient if I use the known value of 40 and 0%. So I have two concentrations of 40%. Okay, I think I mentioned water. It should be oil here. My bad. We have 40% oil, not water. 40% oil. So if 40% of higher value, 0% of lower value because 0% of oil, 0% of concentration when we are dealing with pure water. There is no oil in pure water, meaning 0% concentration. And then you have 25% as the mean value. 40 minus 25, subtract along the diagonals. That gives you 15. And 25 minus 0 giving you 25. Reduce it. 5:3. Now this ratio that you notice is the ratio of the quantities utilized here. The quantity corresponding to 40% of oil is 150 liters. This is 40% oil. So I'm going to write here 150 liters. The quantity corresponding to 0% oil is equal to X liters. These 5 parts, please note, these 5 parts corresponds to 150 liters. We are being asked what does this 3 part correspond to, because we have to find out the value of X. 5 parts correspond to 150 liters. 1 part corresponds to 30 liter. Once more, I'm reducing this to 1 part. 3 parts corresponds to 3 times 30, which is equal to 90 liters. So using the concept or approach of alligation also, it becomes very fast to visualize, drop in the values and solve. When I mentioned overlapping values, let me please clarify in case there is any doubt. 40% oil, and in the second vessel also there is an overlapping 0% oil. So the quantity that overlaps, that quantity that is overlapping is basically oil. There is oil here, there is oil here, and the mixture also has 25% oil. That's how it is the overlapping quantity, and hence I'm going to use 40, 0, 25. If you did want to use 60% of water and 100% of water and 75% of water, you will get the exact same ratio and the exact same answer. The answer would not vary. So whether I use equations or alligation, the answer would not change, but alligation makes things very, very quick. Let's take up one more question. Maybe this time you can try this question, all of you all. If you're trying, I'll give you all 1 minute. If there's any answer you find out, give it to me and then we discuss on it. 60 seconds, timer starts now. All right, guys, any responses? If we place this visually, how many liters of pure alcohol must be added to a 100-liter solution, which is 20% alcohol, to have a solution that is 25% alcohol? Let's place that visually. We have a 100-liter solution that is 20% alcohol. By volume, it is 100 liters. By quantity, is 100 liters. And we have 20% alcohol. We are going to add some pure alcohol to it. How many liters? I don't know. That's the question. So the concentration of alcohol here has to be 100% alcohol. And the result of 100% alcohol mixing with 20% alcohol is a 25% alcohol, a diluted version, diluted from 100% to 25%. And the quantity has to be 100 plus X. So you would notice here that the overlapping quantity that I'm talking about is alcohol, alcohol, and alcohol. The higher value is 100%, the lower value is 20%, the mean value is 25%. Let's place this in the alligation diagram. The higher is 100, 100%. The lower value is 20%. And the mean value is 25%. The quantity associated with the 100% alcohol is X liters. The quantity with 20% alcohol is 100 liters. Subtracting along the diagonal, now that I have understood what my higher value, lower value, and mean value is, and I'm using only the concentration of alcohol in all the three values, 100% alcohol, 20% alcohol, and 25% alcohol. There's no use of alcohol and water. So 100 minus 25 along the diagonals, 75. 25 minus 20 along the diagonals, 5. So the ratio I'm looking forward for is 1 is to 50 by cancelling. Ria, I think this will answer your question also. What does the ratio 5 is to 3 represent in the previous question? I think we can try this on this question and let me know if you got clear with it. The one part here represents the quantity X liters. The 15 parts here represents the quantity 100 liters. This corresponds to 100 liters. If 15 parts is equivalent to 100 liters, one part has to be 100 by 15. What I really want to not utilize is any new variable. 20 by 3 will be my answer. And that is what I need for one part that represents the quantity X liters. Answer has to be 20 by 3. If you want to use variables, you could just create another equation, 15x is 100 liters. It's literally the same thing, but trying to visualize without the variable x, it becomes easier to utilize parts that have 15 parts of the solution, which amounts to 100 liters. So one part is 20 by 3 liters. Had the ratio been 2 is to 15, I'm looking for a value which is 40 by 3 liters. Had it been 4 is to 15, I'm looking for a value which is 80 by 3 liters, 4 times 20 by 3. That's how you would work with these ratios. This is the ratio of the quantities that are being mixed or that are being combined. You can find the exact same answer if you reverse the alcohol to water. You have combined here, if not 20% alcohol, you have combined here 80% water. 100% alcohol is 0% water. And 25% alcohol has 75% water. So if you want to create the alligation diagram with 80 as higher value, 0 as lower value, and 75 as the mean value, you will get the exact same ratio, but in reverse order, 15 is to 1. And with that, one part will still be equal to 20 by 3 because 15 parts will still be equal to 100 liters. So you can, of course, use any of these, water or alcohol, but whatever you use, it has to be consistent across HV, LV, and MV. Ria, is this clear to you? And Pawan? Pawan, after 1 is to 15, you just have to utilize the value of reverse engineer with the value that is given. We have been provided with a value of 100 liters. So from the given ratio, can I utilize this 100 liters and manipulate with the value of the ratio and the 100 liters? So I see that 15 parts is what corresponds to 100 liters. This is the quantity, right? 15 parts corresponds to 100 liters, with which I can find out the value of X liters because X corresponds to one part. Let me please know, Pawan, in the comments if you got this. All right, guys. This is a question where we utilized combining percentages and there was a value given to us. What if there was a GMAT question where they did not give you any values? You just got percentages. Would you be able to solve that? Let's see. I'm going to give you guys a question and I need 60 seconds, 60 seconds of brainstorming on the question, after which we discuss. Absolutely correct, Pawan. Absolutely correct. What is known and in terms of part, what value that is known I can relate to is my quest. I know 100 liters, where does that fit in? Reverse engineer with the ratios. Which ratio does that fit in? So here's a question, guys. Solve this question, 1 minute given to you, and then we will discuss. All right, guys. I got an answer. I'm very happy that someone got that. Let's have a discussion. The question itself, it's a GMAT question that gives away, with the word mixture, you're already thinking on the technique of alligation, because mixture of, it's a combination of percentages as you read through the question. And all you need to find out, is there an overlapping quantity? So there is a mixture X, which is 40% ryegrass and 60% bluegrass by weight. Seed mixture Y, 25% ryegrass, 75% fescue. So I can already see that my overlapping quantity so far is ryegrass and ryegrass in a mixture X and mixture Y. In the combined mixture of X and Y, again, I have 30% ryegrass. So clearly, the other bits, which is 60% bluegrass, 75% fescue, is redundant. And GMAT is notorious for giving you so much of information that you don't need but can confuse you and can consume your time. So careful with the overlapping quantity. Ryegrass, the mixture also has ryegrass. What percentage of the weight of the mixture is X? Now, each of the 5 answer choices also don't give you any value or don't ask you any value in the question. We're just working with percentages here. Between 40 and 25, the higher value is 40%. The lower value is 25%. And the mean value is 30%. I don't have any quantity to work with, but when I subtract along the diagonals and obtain 40 minus 30 along this diagonal as 10 and 30 minus 25 along this diagonal as 5, the ratio is going to be 1:2. And this ratio is the quantity from seed mixture X and seed mixture Y respectively. So if I had to find out the ratio of X and Y, I would get that to be 1:2, which is the ratio of the weight of X and Y. So 1:2, 1/2, 50% would be a trap answer set by the GMAT. Because the question is, what part of the weight of the mixture is X? To find out percentage of the weight of mixture X, I need to first find out the proportion of X. The proportion of X in the mixture, let's say X by Y is 1/2. The proportion of X is 1 part out of 1 plus 2, which is 3 parts. This is the proportion of X. So as a percentage, we are dealing with 1/3 with 100 multiplied 33 1/3%. That's your actual answer. I think MJ got it right. 66 2/3 would be the proportion percentages of Y. 50% would be the trap answer. Okay, guys, this is one more such GMAT kind of a question where it's a question of mixtures, but still they don't give you a value. But using alligation without using any complex equation, you can still find out the required answer. We'll move on. We'll move on from here. Give you another question. Here's a question. Take 1 minute. Give me an answer. I'm glad, Pawan, you got this. Yes, guys, drop in your answers if you have solved it. We won't give you more time for a question like this. Okay. When we get to this question, it's hard to think about alligation on the GMAT. But what is it that can indicate that I can utilize alligation? Let's have a discussion. For somebody who is not really trained practicing, they would look at this problem, they would visualize that there are 50 people, all in all, with an average age of 36 years, because age of all the adults at the party, 36 years. That's the average age. Matthew, again, well done. I'm hoping that you utilize alligation, Matthew. 20 men, they have an average age of 36 years. Then we also have 30 women, average age, I don't know, W years. So if you multiply 36 times 20, 36 times 50, 36 times 50, this is the sum of the ages of all the people. This would be equal to, this is 39. This would be equal to 39 times 20 for the men and 30 W times 30 for the women. This would be the sum total of all the ages and you can solve for W. But this is not what we're going to do on the GMAT. This is not something that is expected. Instead, what we recognize is, we may not recognize alligation, but what we recognize is, this is a question of different weights. This you have to recognize. If you're thinking about a 90 plus percentile, this is the skill you have to develop. It's a question of weighted averages because we're dealing with the number of men 20, number of women 30. These are different weights. And we just have two quantities. If we have more than two quantities, then it's going to be difficult for us to use alligation. Then we can set up an equation, a simple equation. This is where we can think about alligation. Because we have two quantities, we have weighted average as a question, a combined thought process leading you to the thought around alligation. This is how you will build up the mental algorithm. Alligation from the beginning will not be something you will think about. So now let's place this into the alligation diagram. We have a higher value, we have a lower. The mean value will lie always between higher and lower. What are these values? The average here is the value. Because we are combining averages. 39 years is the average age. So per person, per man, the average age here is 39. The age is 39 per person, per man here. That's why this can be the higher value. For the lower value, let's just keep it W years. The quantity for higher value is 20 men. Now, why did I assume that 39 is higher value? Because the mean value is 36. Higher value has to be greater than the mean. 39 is greater than 36. That's exactly why 39 is the higher value and lower value unknown is W years. How many women? The quantity given to us is 30 women. Now you subtract along the diagonals. 39 minus 36, 3. And 36 minus W, because 36 has to be greater than the lower value. Mean is greater than the lower value. Now, if you take the ratio, 36 minus W and 3, we can equate this ratio to 2 is to 3 as the 20 men is to 30 men. Or we could say that, 3 parts here. This is the ratio given. These 3 parts corresponds to 30 men, 30 women. And we could solve around that to find out W years. What I'm trying to say is, let's put it in a simple fraction, 36 minus W by 3. This is equivalent to 20 upon 30. So solving this, you would reach to answer option C. The ratio is 2 is to 3 here. 20 men is to 30 women. That is equal to 36 minus W by 3. All right. Okay. All of you guys, I'm going to move on. This is one of those questions where this was not a direct question of mixtures. It was a question of combining or mixing averages, average ages. But we reached to utilize alligation instead of any long form equation by thinking around this process. Especially with two quantities, be clear, we can use alligation when we are combining them, especially if they're averages or prices or anything associated with the word per. Moving on with that thought process. Here's a question. Again, I'll give you 1 minute and then we'll solve it. Sorry, it's kind of cold this side. All right, guys. Drop in your responses if you have solved for this. Okay. A rabbit on a controlled diet is fed daily 300 grams of a mixture of two foods, X and Y. So we have 300 grams as the weight of the mixture. Food X contains 10% protein and food Y contains 15% protein. I'm already combining percentages here, 10% and 15%. The rabbit's diet provides exactly 38 grams of proteins. How many grams of food X are in the mixture? So 38 grams, but we have been provided with percentages across 10 and 15. If you try to set up an equation to solve this question, you might want to utilize 10% of something, 10% of X, 15% of Y, 0.15 Y, equal to total 38 grams. You also know that X plus Y is equal to total 300 grams, Y is 300 minus X, and you would want to substitute 0.15, 300 minus X, 38. This is one way to think through if you're thinking only around the thought process around equations. But this is what we won't do. Because it's a question where I'm dealing with two quantities on the GMAT. This is also a GMAT question, two quantities, and I'm combining percentages. So this is where I can use alligation. Higher value, lower value, mean value. Higher value by percentage is 15%. Lower value by percentage is 10%. And now the mean value is where you have to be a little careful. If you want to write 38 grams, there will be a problem because I am combining percentages 15 and 10. Writing here 38 grams will be wrong, will not be correct. You have to have overlapping quantity, percentage, percentage, percentage. So now you would like to convert 38 grams into a percentage. So 38 out of 300 into 100 will give you the percentage value, which is 38 by 3%. Now you see the problem here, I'm having a fractional percentage. Because at the end, I'm dealing with only ratios, what I'm going to do is, I'm going to simply multiply a 3 on the higher value, on the lower value, and on the mean value. So now I'm going to work with some new values which don't have any fractional component. I'm dealing with 45%, 30%, and the mean value of 38%. Now you solve along the diagonals, subtract along the diagonals. So you have 45 minus 38, which is 7. You have 38 minus 30, which is 8. Now, this was the percentage composition for y. This was the percentage composition for x. Careful with the quantity. So we are dealing with the ratio of y is to x as 8 is to 7. Right? Now we reverse engineer. We already know the total is 300 grams. So 15 parts, 8 plus 7, 15 parts is given to us as 300 grams. One part is equal to 20 grams. We want to find out how many grams of food X is in the mixture, which is composed of 7 parts. So one part is 20 grams, 7 part has to be equal to 7 times 20 or 140 grams. So answer option B becomes the correct answer without using an equation with two variables where you have to simplify it to one variable and then solve. Got it, all of you? Let me please know, I'm going to move on to the next and our last question, slightly different, and we'll see how we can simplify the question by using just alligation. Here's the question. Here's the question. Please take 1.5 minutes, and then we discuss. Okay. Any answers? Anybody? So This is the question which deals with the price per fruit. 40 cents each apple. And we are combining it with 60 cents each orange. When you're on the GMAT, you have a question like this. Try breaking down every single line to see what's exactly happening. We are combining, right? Because when we combine is when you have the overall price to be 56 cents per fruit. And the total value of 10 is also given to you. You have the weight of the overall mixture. You also have the mixed price of 56 cents. You have the higher price, you have the lower price. If you try to set up equations here, you will need to take, apples and oranges, two variables again and solve for it. Instead, if you realize it's a question of combining averages, price per fruit, I could use higher value, lower value, the alligation diagram, and the mean value, which in this case is 56. The higher value is the price of each orange, which is 60. And the lower price is 40 cents each apple. I'm using the values associated with per apple, per orange. 56 cents per fruit, knowing very well that orange is an apple equal to 10 in this case. Solving and subtracting along the diagonals, 56 minus 60 minus 56 gives you 4. And 56 minus 40 gives you 16. So you would obtain the ratio of the oranges to apples is equal to 4 is to 1. 4 is to 1. We also know that the total number of fruits is 10. So since the total fruits can be divided equally in 4 plus 1, 5 parts, we could say 5 parts is equivalent to 10 fruits. 1 part is equivalent to 2 fruits, which implies 4 parts is 4 into 2, or we have 8 oranges, and 1 part is equivalent to 2 apples. This we already have. Now in the second part of the question, how many oranges must Mary put back? She has to give it back, so that the average price of the pieces of fruit that she keeps is 52 cents. Now in the second part, the average changes to 52 cents. So I'll draw another diagram, but keeping the higher value of 60 and lower value of 40 constant. This is where you have to be a little careful because the average is lowered. Do not assume that that I'm keeping back oranges doesn't imply I'm taking more apples to keep the total to be equal to 10. Don't assume that the total now is equal to 10. The total oranges and apples is not equal to 10. Okay. Now, if you solve along the diagonals, 60 minus 52 gives you 8 and 52 minus 40 gives you 12. The ratio between oranges is to apple is 3 is to 2. But I know for a fact that the number of oranges are changing. Mary is keeping back the oranges. This changes. But the number of apples don't change. I had 2 apples, which initially represented 1 part. Now, the same 2 apples will represent 2 parts in this new alligation equation, the ratio that I obtain. That does not change. So the 2 parts which I obtained in the second diagram has to be equal to the 2 apples which I already found out. That is unchanged. So every 1 part represents 1 fruit. 3 parts would represent 3 oranges. So we had 8 oranges. Now we have 3 parts, meaning 3 oranges. So 3 is the trap answer. The number of oranges she did keep back has to be 8 minus 3, which is 5. If you assume that oranges plus apple is 10, and then you take 3 plus 2, 5 parts is 10, 1 part is equal to 2, so 3 part is 6. We had 8 oranges, now we have 6, and you mark 2, 2 would also be a trap answer. The key here is to not assume that the sum total is 10 fruits. This is a tough GMAT question, tough for those who are not trained and they use complex equations set up with different variables, oranges and apples, set up 2 equations, try to solve them. It will definitely consume 3 minutes or maybe even more. But if you use alligation, this kind of a technique, you will break down the question easily and you'll be able to locate the answer, making sure that, of course, you are not trapped with these kind of details. So I hope these 5 questions give you a quick variety of where all we can use allegation. This will be extremely effective once you start practicing questions of weighted average, questions of combining percentages, averages, or locate situations where you can find out combination of speeds in rate-based question and you think around allegation. There are so many hard questions of profit and loss which can be solved by allegation very, very simply. You can break down an extremely difficult, perceived difficult 705 level question into something around 605 or maybe lesser. You can break it down once you start thinking on the lines of allegation. This doesn't happen on a day. It takes at least a week or two of practice, minimum 20, 30 questions consistently thinking through on the questions to solve using allegation. You would notice that how to use allegation is not a problem. The skill is to realize when to use allegation. So today we did understand first the basics of ratios weighted average, which is the pre-work necessary before you jump into allegation. We understood allegation largely through questions. Where all can be utilized? I tried to bring in different varieties of questions where one can think of allegations, but there are a lot more you can explore as you go through the official questions and specifically of profit loss rates. You can figure out a lot more harder questions that can be broken down with allegations. Let me know what all other topics you would like me to pick up. You can please post it in the comments. I'll think through and pick up a good topic for discussion. But do let me know because your problem point is what we are trying to solve. I hope that this class of 1 hour did give you some value around allegation. You'll go ahead and practice more questions. And I'll see you again on another Wednesday with a brand new topic. Thank you very much, guys. If there is any question, please let me know on the chat box. All right.